Okay, 2.2, Introduction to Problem Solving. Now, with our book, whenever we talk about problem solving, what we really mean here is word problems. So if you ever see problem solving in the homework, in the practice, in the lectures, that means word problems. So we have two objectives. The first one is to write algebraic expressions. In essence, we need to be able to translate from English to math. And second, we need to be able to do some problem solving. And I do have general strategy included here for us that we'll go through in some detail. So let's start with the first objective, writing algebraic expressions. So we have some examples. An example here, two parts. The first one says the sum of three consecutive integers. We're trying to write as an algebraic expression and then simplify, and it tells us to let x be the first integer. So if I have consecutive integers, I have x plus 1, and I have x plus 2. These two come one right after the others. And it says the sum, so I'm going to add an addition to each of these, and then simplify. We have 1, 2, 3 x's plus 3. So that is our algebraic expression for that statement. In part B, the perimeter of a triangle whose sides measure x, 5x, and 6x minus 3. So perimeter, remember, is the addition of all the sides. So we're going to add x plus 5x plus 6x minus 3. And if you want to make a little note here, perimeter, add up all the sides. And then simplifying, we have 6x, 12x total minus 3. And that's our algebraic expression for that perimeter. So that's all it means when we want to write algebraic expressions, right? We need to be able to translate from English to math so we know what to do. So there's some practice for you to get the hang of it there. So now we're going to jump into some problem solving. So I have a little example here. The three most populous metropolitan regions in the U.S., New York, Los Angeles, Chicago, in that order. Now that I'm pretty sure that's accurate actually to this year, the start of this year, maybe not now. The New York area is 6.1 million more than double the population of the Chicago area, and the population of the LA area is 0.1 million less than twice the population of the Chicago area. Write the sum of the populations of three areas as an algebraic expression. Let x be the population of Chicago. So we're thinking about our three towns. We have Chicago, New York, and LA. So Chicago, they tell us right off, is x. So when we're thinking about New York, we have 6.1 million more than double the population of Chicago. So 6.1 million more, 6.1 million. More is your clue for addition. Anytime you see more, you can translate that to plus. Double the population of Chicago. If Chicago's population is x, then double that is 2x. And so now we have 6.1 million more than double the population of Chicago. And for LA, we have 0.1 million less than twice the population of Chicago. So they're saying the same thing, but a little bit different. So we still have a 2x. Only now we're not more than 2x, we are less than 2x, so we're doing 2x minus. So again, just like more equals plus, less equals minus, and it's minus 0.1. And then it asks us to write the sum of all three. So we're just going to have x plus 6.1 plus 2x plus 2x minus 0.1. And simplifying that, we have 1, 2, 3, 4, 5x. 6.1 minus 0.1 is 6. And so there's our simplified expression. So there's a practice one similar to that. And at the bottom of the page here, I have the general strategy for problem solving or for tackling word problems. So the first thing and the biggest thing, and I can't stress this enough, is understanding the problem. So you absolutely need to read the problem. And you may think, duh, of course I need to read the problem. You'd be surprised how many questions I get on word problems that are, I'm not sure what to do. And I say, did you read the problem? And they say, not all of it, no. So make sure you are absolutely 100% reading the problem. Maybe read it twice. I like to read it all the way through once and then reread and look for things to pull out. Maybe they give me variables like let x be population. Maybe they're telling me more detailed information like our two statements here. If they don't give you a variable, choose a variable to represent the unknown quantity that you're looking for. Generally, what we're going to see in the next section is there's a lot of formulas that we have for known quantities, and those have traditional variables that get attached to them. So you're picking the right variable, and in a lot of cases that means picking the right formula as well. And if you can, draw a diagram. Obviously, this problem we didn't need to draw a diagram because it doesn't make any sense. Once you've done that, we're moving on to the translate part. So we're translating the problem into, more often than not, an equation. Ours was an expression, and then we simplified it and we wrote equals because of simplification. And then the final step, if you're translating to an equation, you need to solve the equation. And unlike what we did here, every single word problem exists in the real world. It has context, and your answer should reflect that, so you need to interpret your results. So the most common form of interpreting your results is making sure you have your units. Now this problem didn't have any units because it was an expression to represent population, and we didn't have a value to that population. But if you're solving perimeter and they're giving you inches, then your answer needs to have inches. So this isn't the only way that you can do interpretation. Sometimes they may ask you to interpret your results to give a brief statement about what it means. That's common too. But I'd say 85% of the time, interpreting your results for word problems means making sure you have the right units. So we flip the page here. I want to find three numbers. So we have another little example, word problem. Three numbers such that the second number is 3 more than twice the first, and the third number is 4 times the first. And the sum of the three numbers is 164. So I'm one step down. I think I understand the problem. I've read the whole thing. I do need to choose some variables. So it doesn't give me any variables to look at. So I know I'm taking three numbers. So I'm going to pick x, y, and z. And you don't need to choose these variables. You can choose whatever variables you like. And I'm going to say this is the first, second, and third. Just to balance it in my head, so I know when I reread the problem now what I'm referring to. So now it's saying y, the second number, is 3 more than twice the first, which is x. So y equals 2x plus 3, 3 more than twice. Z, the third number, is 4 times the first, or just 4x. And then the sum of the three is 164. So x plus y plus z equals 164. So now what I can do is use these three equations to solve for each variable. So what I'm going to do is take what I know y equals and substitute it in. And I'm going to take what I know z equals and substitute that in. So we have x plus 2x plus 3 plus 4x equals 164. So 4x, 2x, and x is 7x. Plus 3 equals 164. Subtract 3 from both sides. And we have 7x equals 161. Divided by 7. And as 7 goes into 16 23 times, so x is 23. Now we are not done. We've solved the equation, but it says find all three numbers. So we are responsible for finding all three. This is part of the interpretation. So interpreting this answer is, oh, I haven't found the other two yet. So now I go back and plug it in. 2 times 23 plus 3 equals 49. And 4 times 23 equals 92. So my answer, I'll write it over here, 23, 49, and 92. My answer is not complete without all three. So another practice problem here for you to work, and then this little table is a useful tool that I'm providing you. It's also in your textbook, but it kind of gives you some translations for common things, percentages and fractions. So we have 50%. The meaning is half, 1/2, or the word half. So all three of these things. And the expression, the example that you work out then is 50% of 60 is 30. So you're saying half of 60 is 30. Now that's a simple example because we're trying to make it simple. Might not always be written that way. And there's different things for all different percentages and decimals and fractions, a quarter or 1/4 or 25%, 1% or 1/100th or 0.01 of a number. I've also given you a little breakdown here. 1/10 means move the decimal point 1 place to the left. 1/100th means move the decimal point 2 places. 100% means the whole thing. 200% means double. So this is just a little tool for you to use to get things started. So we're going to use that here in this last example. It says, suppose that a computer store just announced an 8% decrease in the price of a particular computer model. If this computer sells for $2,162 after the decrease, find the original price. Well, it's an 8% decrease, so we want to be thinking, we want to have our critical thinking hats on. That means that this price is 92% of the original. So what I'm saying is 92% of something I don't know, let's call it X, is 2162. So as an equation, you always change your percentages to decimals. So we have 0.92 times X equals 2162. We want to get rid of that decimal, so we multiply by 100. We have 92X equals 216200, 216,200. Divide by 92. And our original price was $235,000. That's too much. It was, silly me, it was $2,235. My goodness. Messed up my decimal there. So there's a practice problem there. It's very similar, but this has been an introduction to problem solving, an introduction to word problems.